Good afternoon to you, boys and girls. We are now proceeding into our lectures for plus one, and the topic is going to be really, very interesting. You will see that most of the things that we are going to do, we are going to start with something very basic, like your class 8th, but the type of questions that we are going to have are going to increase from a very simple to a very interesting level. And sometimes you will be able to know the answer, say today. And as we proceed into the days, the application, the numerical part is going to be very interesting, and hope you are enjoying your lectures. Despite not meeting you all, I do not really know your faces. You are able to see me every day. And I am able to see the enthusiasm in you and the willingness to learn, and you are very eager to come to the classroom. Let's hope so. But despite this lockdown, we are working, and believe me, I am your student and you are my student. We will always remain a student of each other. Now, it is because of your encouragement, your thumbs up signs, you taking the test very nicely, that I am encouraged to come and work here. Work is worship. Come on now, boys and girls. Yesterday, we just learned about motion in one dimension, motion in two dimensions, and motion in three dimensions. Today, we are going to start motion along a straight line. First of all, let's say, what do we mean by a body at rest? We did yesterday, never mind. A body is said to be at rest. And to tell you another thing, that whenever I'm in a class, I always enjoy a cup of tea or a cup of coffee. So it is coffee today, and I always have it black. So you have to get used to it in the video so that you are used to it in the class. A body is said to be at rest if its position does not change with time, with respect to the surroundings. Let us have, okay, we'll write it down. Position does not change with time, with respect to the surroundings, or any reference point. Let's say we have this cup of coffee here. It is in my hand, and the reference is this wall here. There is a wall there. It will not be visible in the video, but there is a wall there. And this is at a distance of at t is equal to 0. When we first observed it, it is at a distance of 3 meters from the wall. After some time we observed, it is again at 3 meters. After some time again, it is again at 3 meters. Its position is not changing with respect to this wall. The wall has been taken to be a reference. So its graphical representation is going to be something like this. This is in table form. This is a new thing is that we have replaced. We have a new word called position. This is time, and this is position x. At t is equal to 0, it was x naught. Naught indicates the position at t is equal to 0. And after 1 second, we saw it was still x naught. 2 seconds, it was x naught. 3 seconds, it was x naught. 4 seconds, it was x naught. And if we plot a graph, position time graph, xt graph, it will be a line parallel to the time axis. This indicates that at t is equal to 0, the position was x naught. 1, 2, 3, 4, 5. At all these times, the position was the same. Thus, this is a graph. For a body at rest, the position time graph is a straight line parallel to the time axis. For a body at rest, the graph is a straight line parallel to the right? Nobody's going to ask you a question in this manner. Okay, what is the body at rest? You just have to know it. You can be asked a graphical representation. Say, I will give you a small assignment of conceptual questions. After you do the theory, you have to know your conceptual questions. I hope the video is working. Yep. Let us try to understand the difference between distance and displacement. As I told you, you have done this in your junior classes. अब रट्टा नहीं लगाना, समझना. Distance. I think you all know it. The total length of the path covered. The total length of the path traversed. A new word for you. I'm using it deliberately. The total length of the path traveled, or I'm using the word traversed. Traversed is Traversed. It is the same thing as traveled. The total length of the path traversed. Displacement. The shortest distance between the initial and final positions. The shortest distance between initial and final positions. I will give you an example. Let's say this is the origin, and the particle goes like this, like this, like this, and reaches here along the path. You know, O, A, C, B. The total length of the path traveled is O, A, C, B. Whereas the displacement is going to be O, B. Right? So distance is OACB and displacement is OB. Okay. This is the right hand, right? This is 3 meters, this is 4 meters. So the total distance traveled is how much? 7 meters, whereas the displacement is going to be given by the hypotenuse, and this is going to be just 5 meters. Okay, another one. A particle is moving in a semicircle, right? A particle is moving in a semicircle, OAB. And this is the displacement. Therefore, the distance traveled is, and it has a radius r, right? The radius is r. The distance traveled is pi r, whereas the displacement is 2r. Okay, another one. A particle moves in a square of side A. It moves from O, A, B, C, O, and back again. This is A. Right? It's very simple. The distance traveled is 4a, whereas the displacement is 0. So I hope we have understood the difference between distance and displacement. I hope we have understood the difference. Let us, from this discussion, let us write some points about distance and displacement. Number one, the displacement is always independent of the path. The displacement is always independent of the path. Because even if this path was, from here to here to here to here, here to here, the total length of the path, the distance traveled would be different, but the displacement would be the same. This means that the displacement of a particle is independent of the path. Next point. For a moving particle, the distance traveled can never decrease. Down shows decrease. For a moving particle, the distance traveled never decreases. Whereas the displacement can decrease if the particle is moving towards the origin, is moving towards the initial point. Let me say in this case, if the particle moves from O to A to C to B and still moves further, so the displacement is going to decrease, but the distance traveled is still increasing. The small minor points which you never bothered about in your junior classes. So we are going to do your 8th, 9th and 10th once again, but in a very interesting manner. You will always have little points to ponder. You will never be asked these points directly. They will be asked to you in a question answer form. Right? So we have displacement is always independent of the path. For a moving particle, the distance traveled can never be negative, whereas the displacement can decrease. And if the particle is moving towards. Okay, another point. The distance traveled is greater than at the most equal to 0. The distance traveled is greater than at the most equal to 0. For a moving particle, the distance never decreases, whereas displacement can decrease if the particle is moving towards the initial point. The distance traveled can never be 0. Whereas if the particle comes back to the original position, the displacement is 0. Okay, we write like this. The distance traveled can never be 0. The displacement can be 0 if the particle comes back to the initial point. Where is my scale? There it is. The displacement is always independent of the path. Okay? For a moving particle, the distance traveled can never decrease. Whereas the displacement can decrease if the particle moves back towards the origin. The distance traveled can never be 0. The distance traveled can never be 0. But the displacement can be 0 if the particle comes back to the original point. And if the particle is moving along a straight line, the distance will be equal to the displacement. In all other cases, the distance will be greater than at the most equal to displacement. Okay. Distance is greater than at the most equal to displacement. For a particle, moving along a straight line, distance is equal to displacement. These points are just very, very interesting points about distance and displacement. I hope it is acha. Another thing what you can add is that distance is a scalar quantity and displacement is a vector. Right? Distance is a scalar. Contains magnitude only. We will do more about scalar and vectors in a very interesting lesson called vectors. Displacement. Displacement is a vector as it contains magnitude as well as direction. Okay. Let me switch on my air conditioner. Just a second. Okay. Let's move further to speed and velocity. Speed. Let's keep it very, very simple. It will be total distance traveled over total time. And velocity, displacement upon time. Right? Speed is a scalar and velocity is a vector. Speed specified with direction is velocity. Speed specified with direction is velocity. If we say a particle has a speed of 20 meters per second, you do not come to know where the particle is going. You just know that there must be a vehicle or a particle which is moving with a speed of 20 meters per second. 20 meters per second. If we say the particle is moving with the speed of 20 meters per second towards Leela Bhavan or towards Model Town, from the Battiyon Wala Chowk, it is moving with a speed of 20 meters per second into Model Town. You exactly know where it is going. Thus, speed with direction specified is called velocity. For a particle moving along a straight line and not changing direction, speed and velocity would mean the same. Right? If a particle is moving along a straight line and it is not changing direction at all, it would mean the same. Actually, you have not read about or done a lot about velocity in your junior classes. You just know the term. और कुछ नहीं है. Velocity बोलना एक fashion था. But as we will do vectors, you will exactly come to know what is the meaning of velocity. Like we can say that speed is the magnitude of velocity. Speed is the magnitude of velocity. Speed contains magnitude only. Velocity contains magnitude as well as direction, out of which the magnitude is speed. Speed is the magnitude of velocity. Okay, an interesting question. The interesting question is, boys and girls, be ready now. Stop writing. You could be, if there is a change in the speed, is it necessary that there is a change in the velocity? Come on, boys and girls. I repeat, if there is a change in speed, is it necessary that there is a change in velocity? Okay, another reverse statement. If there is a change in velocity, is it necessary that there is a change in the speed? एक सही है, एक गलत. Repeat. Okay. You can write down also. मैंने नहीं लिखना. If there is a change in speed, are you sure that there is a change in velocity? Yes. पक्का. यार अगर पार्टिकल की स्पीड ही बदल गई, बच्चे बोलेंगे सर अगर डायरेक्शन बदले, यार अगर स्पीड ही बदल गई, डायरेक्शन बदले ना बदले, तो पक्का वेलोसिटी बदलेगी. Thus, if there is a change in speed, it is surely there is a change in velocity, because velocity contains speed as well as direction. एक बदल गया, पार्टिकल बदल गया. पार्टिकल नहीं, सॉरी, क्वांटिटी बदल गई. The second part says that if there is a change in velocity, are you sure that there is a change in the speed? No, not at all. The particle can have only a change in direction. Only a change in direction will also be called change in velocity. Velocity के पास दो चीजें हैं, speed और direction. एक भी बदली तो चीज बदल गई. So it means if there is a change in velocity, it could happen due to a change in direction only. Thus, a change in velocity would not necessarily mean that there is a change in speed. Acha, if the direction only changes, then are you sure that there is a change in speed? No, not necessarily. हो सकता है कि particle is moving in a circle, or you have taken a turn on your bike with the same speed, there is a change in velocity. Thus, a change in speed will surely mean a change in velocity, but a change in velocity does not necessarily mean a change in the speed. I hope these are the kind of questions that are going to be asked to you after we tell you what speed and velocity is. लिखना जरूरी है. After that, short answer. बाद में ये कुछ नहीं पढ़ते हैं. Whether it is your school exam or your entrance, you have got to know the subject, and then you can attempt any kind of a paper. Okay. Since your class 7 or 8, you have been trying to memorize something called uniform speed. And the definition goes like this: if equal distances are covered in equal intervals of time, or you can say if the position of a particle changes equally, like change in position is called distance. Suppose karo from a certain reference you are at a distance of 5 meters. Okay, this is t equal to 0. At t equal to 0, you are at a certain distance of 5 meters from a reference, say this wall. After some time you are at a distance of 20 meters from the wall. It means you have covered a distance of 15 meters in this time interval. This is change in position. Distance traveled is change in position. Thus, uniform speed, if equal distances are covered in equal intervals of time, howsoever short the time interval may be. Now, why do I say howsoever short the time interval may be? पहले भी आप रट्टा लगा लेते थे. देखो, मेरी बात ध्यान से सुनना. If we have a particle which covers, say, 20 meters every second, यार it is not necessary that the motion is uniform. हो सकता है पहले हाफ सेकंड में 8 मीटर किए हों और अगले हाफ में 12 किए हों. हो सकता है कि अगले हाफ में 2 किए हों, अगले हाफ में 8 किए हों, अगले हाफ में okay, again 20 meters in 1 second. पहले हाफ सेकंड में 12, दूसरे हाफ सेकंड में 8, फिर हाफ सेकंड में 5, फिर हाफ सेकंड में 15, फिर हाफ सेकंड में 6, फिर हाफ सेकंड में 14. हर सेकंड में हो तो 20 रहे हैं, पर ये मोशन यूनिफॉर्म नहीं है. ओके, इफ इट इज कवरिंग इन एवरी हाफ अ सेकंड, इट इज कवरिंग 10 meters. Still you can't say it is uniform, because in 1/4 of a second it could be covering 6 and then 4. I hope you understand. This is the meaning of the term how circle short. The motion is said to be uniform, that even if you consider the time interval to be as short as you want, still the distance traveled should be the same. If you say that it is covering, 3 kilometers in 1 hour, in the second hour also it is covering 3 kilometers, you are not sure that the speed is uniform. The person could be sleeping for the first half hour and then covering 3 kilometers in the next half hour. So the speed is said to be uniform if it covers equal distances in equal intervals of time, howsoever short the time interval may be. जितनी मर्जी छोटे टाइम इंटरवल ले लो, आपका डिस्टेंस ट्रेवल्ड बराबर होना चाहिए. That is the meaning of uniform speed. Okay. For a particle moving along a straight line, uniform speed and uniform velocity would mean the same. We are studying distance traveled along a straight line. We are not going to turn here and there. Okay. Let's have an equation for a uniform speed. Suppose the particle is moving along a straight line with a speed v, right? 20 नहीं, v. ABCD वाला v. v meters per second. It means it is covering a distance of v meters every second. Suppose we are sure that the speed is uniform and it is covering 20 meters. Okay, 20 छोड़ो यार, वो v और v बराबर आ जाता है. It is covering 50 meters in 5 seconds. We know that the distance traveled has been 50 meters in 5 seconds. And the speed is uniform. It means it must be covering 10 meters every second. किया कैसे? 50 over 5. Distance over time. यही इक्वेशन है. उसकी ऐसी हम दफा बना देंगे, देखना. बात इतनी हुई है कि particle at t is equal to t, the position is x. This t stands for time in general, and this x stands for position. We will not write position, but it would mean this. This stands for position. एक बार लिख रहा हूँ. This stands for time. And at a later time t dash, the position is x dash. At a certain time, we saw that the position from a certain reference point was x. Say it was 5 meters. And then after some time, you saw it as x dash. Say it is 55. The position initially was 5 meters. Now it is 55 meters. Distance traveled कितना हुआ? 55 minus 5. यहाँ कितना हुआ? x dash minus x. This means that the position change, that the change in position that is the distance traveled is x dash minus x in a time t dash minus t. थोड़ा सा फर्क पड़ गया ना. डिस्टेंस ट्रेवल्ड डायरेक्टली भी दिया हो सकता है, आपने निकालना भी हो सकता है, बट वी आर राइटिंग डिस्टेंस इन टर्म्स ऑफ चेंज इन पोजीशन. सपोज द डिस्टेंस ट्रेवल्ड इज 50 meters. x dash minus x आ गया 50 meters. x could be 0 also, हो सकता है. बट अगर x इनिशियली है तो फाइनल पोजीशन माइनस इनिशियल पोजीशन इज गोइंग टू गिव यू द डिस्टेंस ट्रेवल्ड. in a time t dash minus t. Therefore, for uniform speed, v is equal to x dash minus x over t dash minus t. We will call this delta x by delta t. And that is why the units are meter per second and dimensions are LT minus 1. Now you know, जितनी टर्म्स हम सारी फिजिक्स में +1 2 में करेंगे उसके यूनिट और डायमेंशन साथ साथ लिखते जाएंगे. हाँ, एनालाइज करना तो आपको सिखा दिया. So the speed is given by delta x by delta t. Delta x क्या है? Change in position. By change in position we mean distance traveled. Okay. This is an equation for uniform motion. Speed is distance over time. Okay. Graphical representation. Okay, I just want to talk a little more about it. You know, if somebody asks you that the cost of 10 bananas is rupees 100, the cost of 10 bananas is rupees 100. What is the cost of one banana? You will say rupees 10. Jaruri nahi hai. It is true if and only if all bananas cost the same. If the price of each banana is uniform. That is why we are doing distance over time. That 100 meters have been traveled in 10 seconds. If the speed is uniform, so 100 over 10, the speed is 10 meters per second. Only if the speed is uniform. Thus the formula distance over time can only be applied for uniform speed. If the speed is varying, then you cannot calculate the distance as speed into time. You can calculate the distance traveled as speed into time if and only if the motion is uniform. Right? Just a minute, I will write this also. Distance traveled for uniform speed is delta x is equal to v delta t. Is it v delta t? Graphical representation. Graphical representation. We can represent it in two ways. Time का नहीं पता लगता पढ़ाते हुए बेटे. We are 33 minutes into the lecture. I'll just take some 10 more minutes. We have to finish this today. One is velocity time graph. Speed time भी बोल सकते हैं. For uniform speed, we mean that the speed does not change. Uniform speed means speed does not change. That is, it remains constant. Suppose a body is traveling with the speed of 10 meters per second. It means throughout the journey, at whatever time you observed, the speed was 10 meters per second. Thus, the velocity time graph, okay, we can have a chart also, we can have, this is time, t in seconds, and this is velocity in meters per second. At t equal to 0, the speed is, let's say, 10 meters per second. At 1 second, it is again 10. After 2 seconds, it is still 10. After 3 seconds, it is again 10. After 4 seconds, it is again 10. And after 5 seconds, It is again 10. Okay? Thus, if we have a velocity time graph, and on this graph, at this scale you have 10, then you have a straight line. The graph with a straight line for a body at rest also, but that was the position time graph. Position is not changing. Here, you have to know how to read a graph. This is the velocity time graph. At t equal to 0, the velocity had some value. And at all times, the velocity had the same value. Thus, the velocity time graph for uniform speed or uniform velocity is a parallel line, is a straight line parallel to the time axis. We must write it down. This expression you should know. This expression you should know. The VT graph is a straight line parallel to the time axis. You have to remember this expression. आदत पड़ जाएगी. हमेशा ही ग्राफ में ऐसे करना है बेटे. Straight line parallel to the time axis. For a body at rest, the xt graph, the position time graph for the straight line parallel to the time axis. Okay. How can we calculate the distance traveled from the velocity time graph? Okay. This is velocity and this is v. This is the time t and this is the time t dash. Right? Just mark perpendiculars from here and call it O, A, C, B. Find the area OACB. The area OACB on this graph is V into T dash minus T. As this time, as this is 0. This is O1. This is O. This is the 0. Okay. Oh, we don't have anything. This is T dash minus T. Thus, area OACB is, do not cram. Physics में कभी याद नहीं करना. देखो. And when we will do some questions to find the distance traveled from the speed time graph, you will then quickly remember it. It is only the application part which makes us understand the theory. Theory in itself in physics is meaningless. But to do the application, you have to know your theory first. Nobody will ask you directly, show graphical representation. You just have to know it and apply it. Area OACB is V into T dash minus T. I hope the area of this rectangle is length into breadth, V into T dash minus T, which we know is the distance traveled for uniform speed. During uniform speed. Okay? This is the distance traveled during uniform speed. Therefore, look at the expression now. Area under the VT graph and the time axis. Area under the VT, this is the VT graph. Area under the VT graph and the time axis gives us the distance traveled. There can be so many questions, but you should know that why it is. We calculated the area. It came out to be V into T dash minus T. The distance traveled is given by V delta T. It's the same thing. Thus, इसको डिब्बे में बंद करो, so that whenever you open your register, you have it highlighted. These are the only things that you must remember. इसको directly नहीं करना, लिख लेना बस एक बारी register में, neat and clean. Just one more thing. Graphical representation of uniform velocity. We have a velocity time graph. Now we have position time graph. चाहे distance time हो, no, but we are representing distance as a change in position. And if we have to find the speed, it is distance over time for uniform speed. It is only for uniform speed that speed will be given by distance upon time. Why? Just as I told you, bete, 100 meters in 10 seconds. The speed is uniform. 10 meters every second. 100 upon 10. Now, position time graph. This is time in seconds and this is position in meters. Okay? At t is equal to 0, the position was, let's say, 10 meters. Right? हो सकता है, 0 भी हो सकती है. T is equal to 0 is the instant when we begin to investigate motion. बड़ा अच्छा लगेगा सुनोगे तो. 1 सेकंड बाद देखा, position was 20 meters. It means distance travel कितना हो गया? 10 मीटर. 3 सेकंड बाद देखा, ये डिस्टेंस नहीं है, ये पोजीशन फ्रॉम अ सर्टेन रेफरेंस आप कहां पे थे? 30 मीटर पे थे. 4 सेकंड बाद देखा, 40 मीटर पे थे. 5 सेकंड बाद देखा, 50 मीटर पे थे. दिस मीन्स ये 2 सेकंड, ये 3 सेकंड, ये 4 सेकंड. ओके, हो जाती है गड़बड़ यार, क्या है? आई एम ऑल्सो ह्यूमन. रट्टा होने लगा हुआ. I have assumed the speed to be 10 meters per second. So if initially it was at a distance of 10 meters, then after 1 second, traveling with a speed of 10 meters per second, मतलब 10 मीटर पे पहले ही था. अब 1 सेकंड में 10 मीटर और ट्रेवल करिए तो वो 20 पे आ जाएगा. 1 सेकंड बाद 30 पे आ जाएगा. इट कुड इनिशियली बी एट 100 आल्सो, फिर 110 पे आता, 120 पे आता. सो इक्वल डिस्टेंसेस आर बीइंग ट्रेवल्ड इन इक्वल इंटरवल्स. In this time interval it covered 10 meters. In this time interval it covered 10 meters. In every time interval it is covering 10 meters. That is why the speed is 10 meters per second. But over here we have to have a position time graph. So in the position time graph, this is position, this is time. X means position, not x-axis. Okay, position. This is time. On a certain scale, it could be, 10, 20, 30, 40, 50. Who's really near it? So the graph will start from here. It could be, 0. This could be 1. This could be 2. This could be 3. This could be 4. This could be 5. The graph would be here. Then it would be a straight line. If the graph would be a straight line, these are the corresponding points here, please. 1 second, 2 second, 3 second, 4 second, and 5 seconds. So whenever you see the graph to be a straight line, if the graph is a straight line, it means that for any time interval, the change in position will be the same. It is a diagonal straight line inclined to the time axis. XT graph is a diagonal straight line inclined to the time axis. Now, let us find the slope of this graph. I'm going to draw another one. X, T. This is the graph. Now, find the slope of this graph. a imaginary line, right? Okay, no need to do. No need to do. Corresponding to this time t, the position is x, and corresponding to this time t dash, the position is x dash. You just find the slope of this graph. The slope of this graph between these 2 points, A and B. By slope means talon. Literally. Tangent theta. Tangent theta is this is x and this is x dash. So this is the slope. Perpendicular over base x dash, and this would be t dash minus t. Tangent theta is going to be x dash minus x over t dash minus t. But this is the speed or velocity, which is equal to v. Therefore, slope of xt graph denotes uniform speed. The slope can be found between any 2 points. Like over here, if I determine the speed here, 30 minus 10, 20. 2 minus 0, 2. 20 upon 2, 10 meters per second. 50 and 10. 50 minus 10, 40. Change in position is going to give me the distance traveled. And the slope of this graph will be the same between any 2 points. It is given by tan theta. So what we have learned today is that for uniform speed, the area under the velocity time graph on the time axis gives us the distance traveled, and the slope of the velocity time graph gives us, slope of the position time graph gives us the velocity. We will post you some questions today on this. Interesting ones. Go through the lecture very nicely. Bye-bye. Have a nice day.